In this video we are going to revisit the single-edge nibble transmission or SEND protocol. About a year ago I posted a series of videos on the topic how those signals should look like and what to look for, but I have also received a few requests from automotive trainers for the code for Arduino Uno that can reproduce such a signal. I have a library that supports the SEND protocol, but this code is heavily optimized for speed and support for various microcontrollers, so it's not readable by a typical Arduino Uno user. And for a while I've been struggling with finding a way to present it in such a way so that it looks like an Arduino Uno code, but still is functional in that it can send the messages in the SEND format. And finally, I think I have a solution, because what I did, I created a web page that you can go to and specify the data that you want to transmit, and then when you selected whatever you want to transmit, you just click on the download, and what the result is a code, an Arduino Uno code that you can upload to your microcontroller and just run it, connect it to your oscilloscope, and you should get exactly the correct waveform that you will be able to decode using, for example, a picoscope, and confirm the checksum and other characteristics of the waveform. One thing to note though is that I used a custom clock tick time of 30 microseconds, so in picoscope instead of the usual 3 microseconds you will have to use the custom 30 microseconds clock tick time. I did that because I needed to accommodate the slower or imprecise functions in Arduino Uno, such as digital write and delay microseconds. So everything kind of runs 10 times slower, but still you will get the same shape of the signal, and the picoscope will be able to decode it just fine. But this is not the only thing you can use the tool for. You can also modify the Arduino Uno code and, for example, introduce glitches or extra transitions or changing the timing of the pulses, and then see how it looks like on oscilloscope, or what happens when you try to decode such a corrupted message. For example, what happens to its checksum. Another thing you can do is play with the sensor type and see what kind of data values are being interpreted by picoscope when you try to interpret the data as a throttle position sensor or a mass airflow sensor. That hex data that you have in the sent message is going to get interpreted as the corresponding values, and you, for example, can understand what hex values correspond to an open throttle and what values correspond to a closed throttle. So lots of interesting experiments that you can do, and I would be glad to hear about your experiences with the tool.